Welcome back, guys. Today we're gonna keep doing our math method. So I'd like to talk about the binomial distribution. So before we're talking about binomial, we have to mention one guy. It's Bernoulli, and it's just like the really expert for the fluid mechanics, and also he really contributed to our math method as well. So in here, he just mentioned really two important experiments. So he imaginary if we just did one time experiment and we consider it is successful and failure. Okay, so if my success probability is p, then my failure probability is just 1 minus p. Okay, so it's pretty straightforward. But what if we add some extra conditions for this imaginary experiment? First one is each of the trial result is success or failure. So basically two outcomes. And the probability will be constant for all trials. So always successful is P and the failure always 1 minus P. Another pretty important is each of the trial are independent with each other. So essentially it means it's not going to affect, when you repeat it, the probability will remain the same. It cannot be increased or decreased. Based on this one, he developed a really good one. It's called binomial distribution. Okay, so the number of success in Bernoulli sequence of nth trial is called the binomial random variable, and it will have the binomial probability distribution. So basically, we don't care about when and what time I get the result or successful. I only care about the overall outcomes. So by this, what I mean is if I try n trials or n times experiment, I only care about the x times successful. So I only select from n from x, I only select x from n. And my successful p will be happens x times, and my failure will happens n minus x times. So I time all of them together, it gives me binomial distribution. And the nx essentially just my combinations. Okay? And the formula is given over here. So let's look at what do I mean. First one, find the probability of obtaining exactly 3 heads when a fair coin is tossed 7 times. So if I toss 7 times, I only want 3 heads. And I don't care it's 1, 2, 3 successful or 4, 5, 6 successful. What I want is you do this experiment 7 times, you only need to pick for me 3 times successful. Okay, so 7 choose 3, and my successful happening 3 times, so 0.5 3 times, to the power of 3, and my failure just happened 4 times. Okay, so 1 minus 0.5, and the power will be 7 minus 3. This is binomial distribution. And if we want to find exactly equal probability by using CAS, we use binomial PDF, okay, to help us find the value. And for example 3, this one we kind of need to find the greater than or equal to, which in this case is 3, 4, and 5. And for each of them, we need to write down the expression. But if we use CAS, just need to remember if we found at least or at most something like that, we just need to use binomial CDF, okay, to help you find the lower bound and upper bound to get the answers. So again, binomial distribution, of course, can combine with conditional probability such that they give this sentence, given that blah, blah, blah would happen, or if something, something happened. So it essentially means give us extra information. In this case, they tell us, given that the score at least 1 go, okay? So which means probability x greater than 1, greater than or equal to 1, right? And for this part is from 1 plus 2 plus 3 until 6, which is quite annoying. So in such case, we use 1 minus the opposite, which means first we get the complementary, then we use 1 minus to get what we want. This skills is pretty important, and hope you guys can notice this one to reduce the calculation. Okay. So my 14b, they gave us the binomial graph expectation and the variance. So for the binomial graph, it's not that important, and essentially just calculate for each probability and draw where it is done. Okay. The name also is not that important. I never see the math method tells test you guys what mean by the shape, like positively skewed, something like that. But for further math students, you should know that positively skewed, symmetrical, and negatively skewed. Okay. For expect value and variance for the discrete random variable, we covered the last videos, and for this one, is just use n times p and np times 1 minus p. Okay. This one is important because it's really useful for us to find the mean and variance, as well as it tells us the shortcut way to do to find the mean and variance. Okay, another thing is this is not given. That's why you need to memorize and understand it. So this 14b is not hard. For 14c, they just like finding the sample size. Previously, for the binomial distribution, we just need to know what's the value for n, and we just need to calculate probabilities. But in this session, we actually give you the probabilities, and we want you to find the sample size, or maybe like the minimum or maximum of sample size. So look at the example. The probability of winning prize in a game is 0.48. And the question is asked at least how many games you need to play to make sure you win at least once. The probability is more than 0.95. This is what they asking. Okay, so for my part A, it's just like probability x greater than 1 will be greater than 0.95. So again, probability x greater than 1 is pretty hard to calculate. That's why we use 1 minus probability x equals 0. 1 minus its opposite, or 1 minus its complement. So which means I never win in the game should be probability less than 0.05. So I use CAS to solve this one. I can get my n value is about 4.58, and we have to take the round up, because we have to play around 4.6 games to get, but we don't have the half game or 0.6 game. That's why we have to play 5 times. Okay. For B, it will be the same thing. It means at least win twice. So you use 1 minus 1 minus not winning anytime, and 1 minus winning 1 time. Okay. And the official method is provided by the CAS. You have to use spreadsheet, and some teacher will teach you how to use a binomial inverse. So just follow your teacher's lead. If they teach you the other method or the quick way, just follow them, and then you can get these answers. But the question essentially still you have to read carefully and to write down the equation first. So for my 14D, they just like proof for the expectation and the variance. This one is just for your own interest if you have time and if you are really want to know why the binomial expectation and the variance is NP and N times P times 1 minus P, you can look at this one. And this is pretty much for the binomial distribution. So for binomial, again, we only have two outcomes, successful or failure, and each of them probability never change. And for each trial, it's independent, so it won't affect each other. And again, we don't care about what time we win or lose. We only want to know the overall times. For example, 10 times I win 3 times. Okay, so that's why we only need the combination to play the role here. Okay, hopefully my video is helpful, and next one we will look at the continuous random variable. Okay, thanks for watching, guys. I see you guys for the next videos. Bye bye.